Hello there, and welcome back. What we're going to do in this video is take the equation of a parabola y squared minus 12x equals 0. We're going to write it in standard form and then use the standard form to identify all of the key characteristics of the parabola, and then we're going to get a sketch of the parabola. So remember that when a parabola has vertex at the origin, that's where we're starting in this unit, it has two possible equations, x squared equals 4py and y squared equals 4px. And since our equation, y squared minus 12x equals 0, contains a y squared term, we know that the standard form is going to match up to y squared equals 4px. So the first thing I'm going to do is add 12x to both sides to isolate the y squared term to one side. And we have y squared equals 12x. And that means right away that coefficient 4p in the standard form is equal to 12. Remember that value of p helps us to determine where the focus is and where the directrix is. So if I solve that for p, I have p equals 3, which means that the focus is 3 units away from the vertex, and the directrix is also 3 units from the vertex. Okay, so since this is a y squared equation, we know that the parabola is going to open horizontally, and since p is positive, we know that the focus is to the right of the vertex. So just as a rough sketch here, here's our vertex at 0, 0, and when it's simply an x squared term on one side or a squared term on one side and a x or y term on the other side, the other variable, we know that 0, 0 is going to be the vertex. So 3 units to the right, we have our focus. And remember, the focus tells us which way the parabola opens, so we know for sure that it's opening to the right. And the directrix is 3 units the other way, so we have our directrix over here, 3 units. Actually drew it a little bit too far, so I'm going to bring it back a little bit. Okay, so there's our equation, x equals -3. Remember that 2 other points on the parabola are endpoints of what we call the lattice rectum. In this case, they're going to be 6 units away from the focus, upward and downward. So if I go up 6 units, 3, 4, 5, 6, we have this point here, 3, 6. And if I go downward 6 units, we have 3, -6, and our parabola passes directly through those points. And there is a rough sketch, I don't know how that got linear there, of our parabola.